Guys, Hess's law, you need to think of it like a puzzle. Okay? Puzzles can be fun. They can be challenging. You just got to figure it out. Okay? Yes, we want to do the outside edges first, right? You got to pick a place to start. Now, for this process, there's a couple of little things I need to go over with you before we actually start doing Hess's law. H2O solid to H2O liquid. That is showing ice melting, right? And you guys know that would take heat to happen. It would absorb heat. It feels cold. And I'm going to tell you that the delta H for that reaction is a positive 6.01 kilojoules per mole. Okay, so I'm giving you that information. Now, what do you think if I did this, H2O liquid to H2O solid? What's the difference in the red one and the green one? Yes. If the red one, if it takes heat to make it happen, then doesn't it make sense to you that the green one, the reverse of that reaction, it's going to have to get rid of heat in order to happen. So you know, if you know this in red, if you know this is positive 6.01 kilojoules, then y'all know this one without me telling you. What would this one be? It would simply be negative 6.01 kilojoules. You don't change the number, you just change the sign. So if you ever flip a reaction around, that's all you do. If it's negative, it becomes positive. If it's positive, it becomes negative. Okay, that's one way we can manipulate an equation. Another thing we have to consider is for that red equation, as it's written, we're talking about 1 mole of ice melting to make 1 mole of water. That's for 1 mole. What do you think would happen if I changed it to 2 moles of H2O solid and 2 moles of H2O liquid? Yes, does it make sense to you guys that instead of being 6.01, it would then be 12.02? You simply double the delta H. Do I have to just double it? Well, no, I could triple it. If I tripled it, then that would be, this would be 3 and 3, and that would be times 3. Do I have to just increase it by a factor? Well, no. If I look at this bottom one, right now it's at 1 and 1. Well, I could, if I wanted to, make that 1/2 and 1/2, couldn't I? Because we love dealing with fractions. So, if I made it 1/2 and 1/2, what do you think that would do to the delta H? Yeah, it would be 3.005. I would just have the delta H. Whatever factor I change the coefficient by, that's the factor I have to change the delta H by. One thing I want to caution you about doing that. Guys, if I double this one, for example, I can't leave everything else alone. Because now, if I put a 2 on the water, is that equation balanced? No. You've got to do it all the way across. And this is a really simple example. Y'all know a lot of times you're going to have like A plus B makes C plus D. If you change the coefficient of one thing, you've got to adjust everything else in that reaction by that same factor. Okay?
What if we start out, like, you know how when we were starting out with the reaction, it was different. It was like the ratio was like 1 to 2.
Okay.
So would that be the same?
Yes, like if you had just 1A plus 2B makes 4 C's and a D, then if I looked at that and for whatever reason I think, well, I'm going to need 4 B's instead of 2 B's, that means I've got to change this to 2, this to 4, this to 8, and that to 2. You just double it all the way across. Okay? This is what a Hess's law problem would look like, y'all. You would be given some reactions. In this one, it's a really simple one. Okay, I'm giving you 2 reactions and I'm giving you their delta H's. And we're going to use those 2 reactions. Those are our puzzle pieces. Okay, we have to make those fit together, add up, to look like this bottom reaction. Now, do you guys spot the difference, because when you first look at it, this first one, CH4 and oxygen, looks exactly like this one. What's the one little difference? Exactly. The first one, I'm producing water liquid. This one that I want, what happens if I produce water vapor? So it's not going to have the same delta H. What we will do is take these top two reactions and we add those up, and they've got to equal what I have here on the bottom. For example, if I were to add them up just like they are, then I would have methane plus 2 oxygens plus 1 H2O gas, all my reactants on the left side, yields CO2 plus 2 H2, well actually it would be 3 H2O liquids, because see, these would add together. It's like two X's and 1 X, they would be 3X, okay? So right now if I add them up, that's not what I want. The things that we just talked about, like flipping a reaction changes the sign, changing the coefficients, etc., that's you manipulating your puzzle pieces so they'll fit, okay? A lot of times students will look at something like this and say, I don't even know where to start. Okay, well, sometimes the good place to start is, what up there in those top two reactions, what is there that when I add them up and I have the bottom, I don't want it there anymore. I need it gone. Do you see anything that I've got to get rid of? Yes. Do y'all see that the liquid water, I don't want it to show up down here at all. So if you think back to when we did those spectator ions, remember that? If it was the same thing on the reactant side and the same thing on the product side, we could cancel them out, couldn't we? So if I can put these waters on opposite sides, I can cancel them out. Okay? So what I see, if I want these H2O liquids to cancel, why not just flip this bottom equation? Does that make sense? Ish. Okay, fair enough. So what I'm going to do, y'all, is I'm going to take the H2O gas to H2O liquid, and I'm going to change it around to say H2O liquid makes H2O gas. Why am I doing that? Because I want to try to get these waters, these liquid waters, on opposite sides so they'll cancel. Yes. Since I flipped that equation, what does that do over here to my delta H? Instead of being a negative 88, I have to change this to a positive. Remember, when you change an equation, you've got to adjust the enthalpy accordingly. Now, when I flip it, y'all, I'm going to go in here and I'm going to mark this one out because I've already flipped it, so that original blue one isn't there anymore. Now, my liquid waters will cancel, but will 2x and x, will that cancel completely? Because that's what I have right now. I have 2x over here and I have x over here. How am I going to fix that?
Put a 2 on both of them.
Yes. If I look at this, hang on, I'm changing colors. If I look at that bottom equation, if I make this 2, then it'll cancel all of the ones up here. But if I make that one 2, I have to carry that all the way across. I have to make this 2. So if I double both of these, it's, tell me what again? It's a positive 176. And that's kilojoules. I have running out of room. Any questions yet? We're not done, no. Will anything cancel? Is there anything the exact same thing on the reactant side as the product side? Here's an H2O liquid on the reactant side. Here's 2 H2O liquids on the product side. Those will cancel out, won't they? Because if you have things on opposite sides of the equal signs, can't you cancel those out? Whatever you do to one side, you do to the other. So I'm going to subtract 2 waters from both sides. What's left after I cancel those out? Look. I've got methane left. I've got 2 oxygens left. I've got 1 CO2 left. and I've got 2 water vapors left. That's all that's left. So now, these pieces add up to be this. So how do I get the delta H for this? I simply say negative 894 plus a positive 176, and that will give me my answer. And I get negative 714.4 kilojoules. And that's my answer, and that's Hess's law. A really simple one.